Hello students, welcome back to our channel Diksha Karnataka. So as you know already the mock test 4 has been released on Monday. So we will be discussing the chemistry solutions part 2. Previously I have released a video where we have discussed the solutions from question number 1 to question number 30, which was part 1. And in this part 2 we will be discussing from question number 31 to 60, right? And if you haven't downloaded the question paper yet, you can go to the join our WhatsApp channel, and from there you can get the question paper. So solve them and then check the answers. Okay, so now let us see the first question, that is today's first question 31. Activation energy is given. Okay, K1 K2 are the rate constant at two different temperatures T1 and T2. So we have to find out which equation it relates. So very simple question, Arrhenius equation, ln of K2 by K1 is equal to EA by R 1 by T1 minus 1 by T2. Okay, so very small differences are there in all the options. I'll tell you. See, if ln is there, we should not write 2.303. 2.303 will come if log is there. So this option is incorrect. Similarly, here it is 1 by T1 minus 1 by 2. So this part is wrong. So that is why this option is incorrect. If you see in option C, the plus has come, right? It has to be minus. So that is why this equation is also incorrect. So the correct answer for this question is option D. Very simple, direct formula based question. Okay, next, cathode reaction in dry cell. We know manganese oxide and ammonia. So the correct answer for this question is option B. Theory based question. Okay, which of the following has the highest freezing point? This is little tricky question. See here. Whenever a solute is added, the freezing point decreases, right? So what is delta TF? I into Kf into M. Now if IM value is very high, okay, then freezing point depression will be more and freezing point will be least. So what we have to find means, what I can say is, if IM value is less, then delta TF will be less and then freezing point of that solution will be maximum, right? So for all these options we can calculate the IM value, right? So I value is 2 here and 0.01, so I'll get 0.02. Then here we will get 0.03. Then in option C we will get 0.1. And in option D we will get 0.2. So you see, in which of the following IM value is the minimum? That is in the first option. So depression will be minimum and the freezing point will be maximum. So correct answer is option A. Okay. Now let us go to the next question from chemical kinetics. Okay. So the rate constant is given, rate law is given to you. So you can see it is a second order reaction, 1 plus 1. So N value is equal to 2. What is the unit of K? You have to remember the general unit of K is mole, 1 minus N, liter, N minus 1, second inverse. So K value will be mole minus 1 liter second inverse. So I can say this one, the correct answer for this one will be mole minus 1 liter second inverse. That is option C. Okay, next go to the 35th question. Half-life period of the first order reaction is given with initial concentration this much, initial rate this much. Then we have to find out the half-life. Okay, so you can see it is a first order. So can I write rate law is equal to K into A, right? So what is rate value? Rate value is 0.00352 is equal to K into what is 0.01 is A value, right? Then can I write K is equal to 0.00352 by 0.01, right? Now this is my K value. Half-life is asked, right? So can I write half-life is equal to 0.693 by K value? So that is equal to 0.693. I can substitute this K value here. 0.00352 divided by 0.01, right? So you can solve this equation. Then the correct answer for this question is option B. Okay, next. Okay, we have to tell the incorrect statement. Okay, so let us first write down the differential equation. Minus dp by dt is equal to minus dq by dt is equal to 1 by 2 dr by dt is equal to ds by dt, right? Now you can see, let us check all the options. Rate of appearance of P. So now one more thing, the word disappearance should be used for reactants and the word appearance should be used with products. Okay, why? Because with the rate of, when the reaction continues, reactants concentration keep on decreasing and product concentration keeps on increasing. So we will tell rate of disappearance for reactants and rate of appearance for products. Okay, so rate of disappearance of P is equal to rate of appearance of S. Okay, this is correct. We have to tell the incorrect one. Okay, next. Rate of disappearance of Q is equal to half of rate of disappearance of R. Okay, so this is also correct. Next is rate of disappearance of P is equal to rate of disappearance of R. Okay, you can see here rate of disappearance of P. Okay, rate of disappearance of P is half of rate of disappearance of R. This is the relation, but what it is given? They have given rate of disappearance of P is equal to rate of appearance of R. So that is why this statement is incorrect. Let us see the next one. Rate of disappearance of Q is equal to half of rate of disappearance of R. So this statement is also correct. The correct answer for this question is option C. Okay, once again we can see the statement which is incorrect. Okay, so rate of disappearance of P is equal to rate of disappearance of S, that is correct. Rate of disappearance of Q is equal to half of rate of appearance of R, that is also correct. Rate of disappearance of P is equal to rate of disappearance of R, that is incorrect because it is 1 by 2. And then we have rate of disappearance of Q. Rate of disappearance of Q is equal to rate of half of rate of appearance of R. So yes, this all three statements are correct. Statement C is incorrect. Okay, next. What will be the rate equation for the given reaction to have zeroth order? So we know R is equal to K, A to the power of 0. So that is R is equal to K. So the correct answer for this one is option B. Which of the following is not an application of electrochemical series? Okay. So to compare the relative oxidizing and reducing power, yes, this is an application. By seeing the reduction values, we can compare. To predict the evolution of hydrogen gas, so this is also there. So the metals whose reduction potential is more than hydrogen, like copper, cannot produce hydrogen gas, right? Then to predict the spontaneity of the reaction, yes, that is also an application. To calculate the amount of metal deposited on the cathode. So electrochemical series has nothing to do with this we calculate using Faraday's law. So the correct answer for this question is option D. Theoretical, but you have to be little thoughtful. Okay, next. The reduction potential for the half cell is Ag plus concentration is given, E naught value is given. Okay, very simple one. So what is happening here? Ag plus 1 electron will give you to Ag, right? We can write the value E of the cell or E of the electrode is equal to E naught minus 0.06. I'll take for easy calculation. Number of electrons is 1 log of Ag concentration, we have to take 1. I have told you it is always the ion concentration should be taken. What is Ag plus concentration? 0.1, right? Now E of the cell we have to find out. E naught of value is already, so it is not actually E of the cell. I can write here E of Ag plus to A, right? Electrode potential. So E naught value given to you is 0.8 minus 0.06 log of 10 to the power of minus 1, so it will become plus 1. So that is 1. So I can write 0.74. So the correct answer for this question is option A. Okay, next. Henry's law constant is given to us. Okay, mole fraction is given at 760 mm of Hg. We have to find out. So what is the formula for Henry's law? P is equal to Kh into mole fraction of the gas. So what will be mole fraction formula? P of the gas by Kh, right? So we can substitute mole fraction. P of the gas given is 760 mm. Okay. And then we have KH value is 4.27 into 10 to the power of 5. Now see, you need not solve it. You can see something, if you can write down this one as to 10 to the power of minus 5, right? Then if we divide it, this minus 5 power can be adjusted to minus 3, and all other options are not having any power. So if you solve this also, you will get the correct answer as option A. Okay, next. What is the mole fraction of ethanol in vapor phase? Yes, this is one important formula. If the solution contains equimolar mixture of ethanol and methanol, given P naught of ethanol is 90 and P of methanol is 46. Okay, see here. First of all, we'll calculate what is the formula of mole fraction in vapor phase. That is equal to pressure by PA by P total. Okay, so we were asked to calculate for vapor phase of ethanol. So I can write P of ethanol by P total. So for that, first we have to find out this PET and P total. So what is the formula of P total? Using Raoult's law, we can write mole fraction of methanol into P naught of methanol plus mole fraction of ethanol into P naught of ethanol, right? So if both are equimolar, so let's, for example, methanol I'll take half x mole and ethanol also x mole. Then what is the mole fraction? Mole fraction of methanol will be x by 2x, that is half, right? Similarly, both will be half. So I can write it here 1 by 2 into, what is the P naught of methanol? 46 plus 1 by 2 into ethanol is 90. So I'll get 23 plus 45, that will be 68. So total pressure is 68, and what is the pressure of ethanol? 45, right? So we can substitute here. Mole fraction in the vapor phase will be 45 by 68. So you can solve this. The value will be getting will be around 0.34. So the correct answer for this question is option A. So this question is little, I'll say this formula you may not have remembered. So please keep it in mind. Mole fraction in vapor phase will be the pressure divided by the total pressure. Okay, next. Which of the following exhibits the highest boiling point? So here, if you remember, we have done just for freezing point. In freezing point, for highest freezing point, IM value should be low. Okay, but for highest boiling point, the IM value should be more. Okay, for highest freezing point, IM value should be least, and for highest boiling point, the IM value should be maximum. So you can just calculate here. This is 0.1, this is 1, this is 0.01, and this is 0.001. So the highest value will be option B. So the correct answer for this question is option B. Okay. Next. Which of the following is more stronger acid than phenol? Okay, so the question is from alcohols chapter. So we should know, if any electron withdrawing group is there, acidity will increase. If electron donating group is there, acidity will decrease, right? So you can see here, I'll draw the structures for both. So first is ethanol. Okay, next we have phenyl ethanol. Okay, next we have para-nitrophenol. So here I think everybody must be knowing that nitro group is a very strong electron withdrawing group, right? NO2 is a very strong electron withdrawing group. It can stabilize the conjugate base, and hence the acidity will increase. So the correct answer for this question will be option C. Okay, next. Arrangement of the following compounds. Okay, so you have to arrange them in the increasing order of their boiling point. Okay, so boiling point depends on two things. It is directly proportional to mass and inversely proportional to branching, right? So bromoethane formula is CH3Br, bromoform is CHBr3, chloromethane is CH3Cl, dibromomethane is CH2Br2. So as the mass will increase, the boiling point will increase. So bromine mass is more. Here we have 3 bromines. So this one will have the maximum boiling point. Right. So you can see which option is having the second one. Yes, this can be the answer. This can be the answer. We can eliminate option B and D. Now you can see here this compound is having 2 bromine group. So that will be the next compound. So the correct answer for this will be option C. Okay, next. Compound A is there, okay, which is treated with concentrated HNO3 and H2SO4 to give a compound B, which is then reduced in presence of SnHCl to give aniline. You know the structure of aniline, benzene with NH2 ring. So what should be A? So see, this reaction can happen when you give nitro group, right? And nitro group can be produced from benzene ring. So the correct answer for this question is option B, benzene. Okay, very easy question. Next, which are a pair of geometrical isomers? So geometrical isomers will have cis and trans form. Okay, what should be the condition? See here, whenever you are having C double bond, okay, these two groups, this one which you add here, X and Y, okay, for geometrical isomers to exist, X should not be equal to Y, right? This condition has to be fulfilled. Now, if you see the options, for first option you see bromine, then it cannot undergo geometrical isomerism. Here also methyl group is there. So that's why that will also not show geometrical isomerism. Here you can see these are two different groups. These are also two different groups. So now this case your cis and this is your trans. So the correct answer for this is 2 and 4. So 2 and 4 is there in option C. So 2 and 4 can exhibit geometrical isomer. So correct answer will be option C. Okay, next. For the reaction, this one, the value of Kp by Kc. So the question is from chemical equilibrium. So first of all, we should know what is the relation. Kp is equal to KCRT to the power of delta N. Now delta N is what? The number of gaseous moles of product side minus number of gaseous moles in the reactant side. So if you see the reaction is like this. CO plus Cl2 gives us CoCl2. Gas, this is also gas and this is also gas. So what is delta Ng? 1, right? Minus this side it is 2. That is minus 1. So I can write Kp is equal to Kc RT to the power of minus 1. So I can write Kp by Kc is equal to 1 by RT. So the correct answer for this question will be option D. Okay. So this formula is the basic, one of the important formula in chemical equilibrium. So you have to remember. Okay, next. So this is important question from common ion effect. Solubility product plus common ion effect. Okay. See here, the solubility product of MgF2 is given to us. Calculate the solubility of MgF2 in this much NaF. So see here how MgF2 will dissociate. It will dissociate to give you Mg2 plus 2F minus. Okay. So let the solubility of this be S and 2S. Right. Now when NaF is present, how will it dissociate? Na plus and F minus. The concentration of NaF is 0.1. So this one will be 0.1 and this one will also be 0.1. Now if you write Ksp formula for this one, Ksp of MgF2, that will be the concentration of Mg2 plus into concentration of F minus to the power of 2, because here we have the coefficient is 2. So now you can substitute. For magnesium it is S, but see for F minus there is a common ion, right? Here also S is there, fluorine is there. This fluorine comes from sodium fluoride. So the total will be 0.1 plus S. Okay. Now what happens, since this one is a strong electrolyte, the concentration of this S or this will be very negligible. Okay, so we can ignore this S because this undergoes complete dissociation. So we can write down this equation as, what was the Ksp value? 7.4 into 10 to the power of minus 11 is equal to S into this one will be 0.1. Okay, here square is there, so 0.1 to the power of 2. So I'll get 7.4 into 10 to the power of minus 9. Okay, so the correct answer for this question will be option A. Okay. So this one is little difficult question because it includes both ionic common ion effect and solubility product. Okay, next. A sample of pure water contains this much gram of sodium, this much gram of, this many atoms of carbon and 0.1 mole of oxygen atom. Its empirical formula is. Okay, so this is from your first chapter, some basic concepts of chemistry, easy one. So what are the elements given? Sodium, then we have carbon, and then we have oxygen. So sodium is 1.15 gram divided by 23. Then here this is 3.1 into, we have to convert it into number of moles, right? So if given mass is there, so given mass by molar mass is the number of moles. Then 3.1 into 10 to the power of 22 by 6 into 10 to the power of 23. And then oxygen is 0.1. Okay, so if you divide this, we'll get 0.05 here. This is 0.05 and this is 0.1. So we can divide, this is number of moles. Then simple ratio, to find out simple ratio, divide all this with the smallest number. So 0.5 divided by 0.5 will get 1. Here you have to divide this one like this, 0.05 divided by 0.05, that is equal to 1. Here again 0.05 divided by 0.05, that is equal to 1. Here 0.1 divided by 0.05, so that value will be 2, right? So now if you write the empirical formula, we will get sodium 1, carbon 1 and oxygen 2. So the correct answer for this one will be option B. Okay, so easy question, but this conversion, how to find the number of moles, that you have to be, you should be knowing. Okay, next question, which of the from structure of atom? See, from structure of atom, quantum numbers and Bohr's theory is very important. Focus on those topics. So let us discuss quickly what are the range. For principal quantum number, any value can come. For azimuthal quantum number, values are from 0 to n minus 1. Then from magnetic quantum number, the values are from minus L to plus L. And for spin quantum number, the values are plus minus half. So now if, okay, now n is equal to 4 means L is equal to 1 is possible. M value can lie from minus 1 to plus 1, so 0 is also possible. Spin quantum number is plus half, so this can be a quantum number. This can be a set of quantum numbers. Now for option B, n is equal to 4, so L is less than this, so that is also correct. But see, M can also be 3. See, for n is equal to 4, the L value are, it can be from 0, 1, 2 or 3, right? So 3 is given, that is correct. The ml values can be minus 3 to plus 3, right? So plus 3 is given, so that is also correct. And spin can be minus half, so this combination is also possible. Now for seeing this one, see, if we consider this part where we have n value is equal to 4. So if n value is equal to 4, see, if n value is equal to 4, then what we'll get, L value can be 1, that is possible. But ml value should lie from minus 1 to plus 1, right? But what is the ml value given here? Plus 2. It cannot be more than plus 1, right? So this combination is not possible. So the question was asked which is not possible. So the correct answer for this question is option C. Okay, next. Which of the following is expected to have highest electron affinity? Okay, so first of all, you can see here, these are half filled orbit, like one more electron if you give here and one more electron if you give here, will get fully filled orbitals, right? So option A and D can have more tendency to gain electrons, right? Because once if they gain one more electron, the 2p orbital will be fully filled. So now this one, option A is for chlorine and option D is of fluorine, right? So if you know the electron affinity of chlorine is more than fluorine, although fluorine is smaller in size, but the electron affinity of chlorine is more due to small size of due to the small size of fluorine, there will be electron repulsion, as a result of which the electron affinity of fluorine is less than that of chlorine. So the highest electron affinity is for option A. Okay. Now see the next question. Which of the following compound has magnetic moment is equal to 0? So you can just see the structure of all the options. CCl4. This is square planar complex. Dipole moments are in opposite direction, right? So they will cancel each other and the net magnetic moment will be 0. If you see CHCl3, right? So these are having in all in different directions, so that will not be cancelled. In HF also, the dipole moment will towards the fluorine. In NH3 also it is not cancelled because the dipole moments are towards nitrogen. So the net dipole moment is 0 in case of CCl4. So the correct answer is for this question is option A. Okay, next, which of the following relationship is true? So bond dissociation is given. So you have to remember one trick. So if bond order, okay, if bond order is high, then bond dissociation energy will also be high. Now how to find bond order? So you should remember one table here. If the number of electrons is 14, bond order will be 3. Then if the number of electrons is 15, it will be 2.5. If it is 16, it will be 2, 17, 1.5 and 18, 1. Okay. So you have to decrease by half. Similarly, if you go other side, 13 is 2.5, 12 is 2, then 11 is 1.5 and 10 is 1. Right. Now let us see. So what are the values given here? O2 and O2 minus. So O2 has how many electrons? 16 total, 8 plus 8. So for 16, what is the bond order? Bond order for 16 is 2. And we have O2 minus. So here the total number of electrons is 17. So for 17, the bond order is 1.5. So you can see, so if bond order of O2 is more, then the bond dissociation energy of O2 will be more. So what is the question given? Bond dissociation energy of O2 and O2 minus are same. So that is not correct, right? So what is the conclusion here? Bond dissociation energy of O2 is more than bond dissociation energy of O2 minus, right? Now similarly you can check for all the options. You can check for now O2 plus. So what will be O2 plus? The value for O2 plus will be, you can write here. Okay. So value for O2 plus will be 8 plus 8, 16 minus 1, that is 15. So bond order is 2.5, right? And bond order of O2 is 2 and bond order of O2 plus is 2.5. So the bond dissociation energy of O2 plus is higher than that of O2, right? So that is the correct statement. So the answer for this question is option B. You can check with the other options also. Okay, next question. The IUPAC name. Okay, this is simple one. You have to just name. The first thing is find the longest chain. 1, 2, 3 and 4. So on second position we have double bond. First position we have bromine. So the correct answer for this one will be 1 bromo but 2 ENE. Okay, so the correct answer is option B. Very easy and direct question. Okay, next. What will be the heat of reaction? So we have came to thermodynamics now. You have to find out whether the reaction is exothermic or endothermic. Okay, so you can, what is the formula? Delta H of the reaction is equal to delta H formation of products minus delta H formation of reactants. Okay, so in this equation what is there? We can write 3 times of delta HF of water, okay, and Fe is in already in its native state. So the elements which are in the native state, for them formation energy is 0. So for H2 also it is 0 and for Fe also it is 0. So we'll get this one minus delta HF formation of Fe2O3, that is minus 8 to 4.2. Okay, So we can substitute the values. 3 times of minus 2. Why I am taking 3? Because in the reaction we have 3 H2O and 1 Fe2O3. So 3 into 285.83 plus 824.2. So if you solve this, you will be getting minus 33.3. Okay. So minus 33.3 is there in option C, and since the delta H is negative, the reaction will be exothermic. So the correct answer for this question is option C. Okay. Fine. Next question. Which of the following statements is not correct? Okay. For a spontaneous reaction, delta G must be negative. Yes, that is correct. Enthalpy, entropy, free energy are all state variables. Yes, that is also correct. A spontaneous process is reversible in nature. See, this statement is wrong. A spontaneous process is irreversible in nature. Then total of all the possible kinds of energy of a system is called as your internal energy. Yes, that is also a correct statement. So the incorrect statement is your option number C. Okay, next, oxidation number of sulfur in peroxomonosulfuric acid. See here, whenever peroxo comes, you should be little careful. The structure will be having some peroxide bond. Okay, so we can draw like this, H2. So the structure of this one you should know is like this. We have one peroxy linkage. Okay, so this oxo I can write this oxygen, this is -1, this is -2, this is -2, and this is -1. So we can write X -2 -2 -1 is equal to 0. X is equal to +6. Okay, so the correct answer for this question is option number C. Okay, easy one. Okay, next, what is the reaction given below called? Okay, so this one is a simple one. See, two water molecules are reacting. Then from this, one is dissociating as H plus and OH minus. This water molecule abstracts this H plus to form H3O plus, and what is left behind? OH minus. So this reaction is called as autoprotolysis of water. Okay, so correct answer is option D. So the water is getting protonated by another water molecule. So that is why it is autoprotolysis. Okay, next question. Number of electrons present in 18 ml of water. For this question, one thing you should know is density of water is 1 gram per ml. Okay. Now if I write, what is this mass of density is equal to mass by volume. So mass is equal to density into volume. Density is 1 gram per ml and volume is 18 ml. So I'll get 18 gram. So total in this 18 ml of water, what is the mass of water? 18 gram of water is present. Then what is number of moles of water? Number of moles of water is what? Given mass by molar mass. So given mass is 18 gram and molar mass of water is also 18 gram. So I can write that is 1 mole. Right, that is 1 mole. Now you see here, in 1 molecule, okay, in 1 mole of water, okay, so in 1 molecule of water, sorry, how many electrons are there? 8 electrons are there in oxygen, and each hydrogen has 1 electron. So I can say total 10 electrons are there, right, in 1 molecule. Now that in 1 mole, how many molecules are there? 6.02 into 10 to the power of 23 water molecules are there, right? And in 1 molecule, 10 electrons are there. So in these many molecules, how many electrons will be there? 6.02 into 10 to the power of 24. Okay, so the correct answer for this question is option C. Next, the scientific notation of this one. So this is from your first chapter, some basic concepts of chemistry. So in scientific notation, before decimal you have to keep one number, right? So you have to put the decimal in this position. 5.4 should be there. So how many is 1, 2, 3, 4, 5, 6, 7 and 8. So the correct answer will be 5.4 into 10 to the power of -8. So the correct answer for this question is option B. Fine, that was the last question. So please solve all the questions, and if you find doubt in any of the questions, you can comment down. I'll personally answer to those questions, or if you have any other doubt, you can just tell me in the comment section. Okay, And if you have liked this video, if it is useful for you, so please like, share and subscribe so that you can get more updates for your preparation. Thank you.